Welcome back to Data Innovation Summit 2019. I'm joined here by a member from Teradata. Please introduce yourself.
Hi, my name is Paul Ibberson. I'm a senior architect with our Teradata EMEA organization.
Cool. So you're going to give us a bit of a tech update in Teradata.
Yep. So we're going to talk today about Teradata Vantage, which is our new product.
Okay.
It's been on the market since last autumn, and kind of just walk you through some of the sort of features and functions of that.
Okay.
Okay. So what we have here is our what we consider sort of the big analytical ecosystem that we see in our customers. So some ways of ingesting data from various sources, there's different ways of storing data, and there are different analytical engines for doing things on that. So SQL engines, the more traditional data warehousing side of things, but we've got machine learning, graph engines, the more data science type activities that come along recently. Also, there's support for multiple languages, and then there's lots of different tools that our users would use to do stuff.
Yeah.
So this is the big, broad ecosystem.
A lot of stuff to glue together.
Absolutely, there's a huge amount of stuff there. So where Teradata Vantage comes in is actually these lighter blue areas are things that we've now established into Teradata Vantage. We have our relational data store. Teradata has been a data warehousing company for 30 plus years now. This is where our strength is in our SQL engine around that. So I've got a new SQL engine, which I'll talk a bit more about in a moment, against that relational database, but we've also got machine learning engines and graph engines built on top of this as well. Okay. And we're supporting lots of languages for access into that data, and we have always supported a huge amount of different tools in the user community, so our BI tools and our partners like MicroStrategy and Cognos, along with newer tools like Jupyter Notebooks and things like that, so to support the data scientists.
I see you support C, C++, and Perl.
Yep.
That's a bit esoteric compared to others. They
don't absolutely, but these are languages that are still used by lots of our customers. And some of these are natively supported like Python and are natively supported inside the database. Things like Perl and C, we do actually have libraries to allow you to connect through to Teradata as well. Yeah.
And the graph and the machine learning stuff, those are built in?
Yeah, so I just kind of show you a little bit more here in the architecture in detail. The Teradata Vantage platform has a data store. It's actually our relational database platform, as we've always done as Teradata. And then attached to our high-speed fabric, which is our secret source for moving data around very, very quickly, we've got these three engines, one of which is the new SQL engine, which is SQL on steroids, effectively. It's not just your father's SQL engine, just basic aggregate functions. Now it actually has some very advanced analytic functions in there as well, like session, path, and things like that is built on top of it.
Okay.
And the machine learning engine and graph engine are additional engines which can access this same set of store of data, so the data remains in one place, but actually the user can come in with a SQL query, call a graph function, and that engine would then respond to that graph function and provide the answer back through to SQL to the actual end user.
Can you give examples of what kind of machine learning algorithms could people use?
Yeah, so we've got some functions here. Build. These are the additional functions for that SQL Plus engine, the new SQL engine, sorry. So we've added, we've got sessionize, attribution, path, and pattern. These are all inside SQL, so this is why we're calling it new SQL. It's extended further out from where the normal SQL engine would be. We also have a set of scoring functions as well, which if you created a model either in one of these engines here, or maybe in an external modeling tool, even something like SAS, you could publish the model into Teradata and then score it directly on the database itself without having to use the other engines, the other tool itself.
You can use the models you've developed in SAS and put them back into the database.
Absolutely, yeah. And we also have native support for SAS as well. If you wanted to, if you're a big SAS user using Teradata, you can use SAS to develop your models and then actually use, we have some SAS functions available that you can then actually use inside of Teradata as well. We have a strong partnership with SAS to be able to do that.
Interesting.
The other aspect here in the new SQL engine is we have this thing called 4D analytics. This is very unique to Teradata. Okay. So typically these things like geospatial and temporal and time series, they are normally done in silos. There are tools on the market which satisfy geospatial, like Esri and things. There are obviously time series products on the marketplace as well. But what we've done is brought these three capabilities together in one single platform. So geospatial, we actually have a very specific geometry data type, which allows you to store three-dimensional objects inside of Teradata.
Three-dimensional?
Yeah, so the X, Y, Z coordinates of
okay.
Yeah, so not a three-dimensional image, but actually the coordinates of
lat, long, and height.
Exactly. Or if you've got
altitude.
The oil and gas industry, I'm doing a lot of work with at the moment. We're doing a lot of obviously depth, underground, subsurface things. But we also have a lot of functions to enable you to expose that data and use that data as well from a geospatial perspective. In terms of time series, this is the latest feature that's come with Teradata Vantage. We've got two things that brings along. One is a primary time index. So actually we can actually store time bucketed up and store the data in that way. So you're actually shaping the data so you can actually access it. But then we actually bring along some time-aware aggregates. So you can actually do a query and then group by time.
Right.
So you can actually see how something looked at a particular point in time and the whole time series side of things. And then the other side of things is temporal, which is how it changed over time. So start date and end date. And this is built naturally into the database. So you can just insert data into a table that has been marked as a temporal table, and it will create those start and end points as the data things.
Would that work with geospatial as well?
Yeah. So this is the great thing about this is that we've actually brought all these things together. And so in one database platform, you can actually have geospatial, temporal, and time series nature of the data all being stored at the same time.
And you would still be using SQL to modify this?
Absolutely, yeah. So just standard SQL statements that allow you to access all of this. We've got some aggregates which are aware of how this data is stored and shaped. And we have some very specific functions which allow you to expose that data and manipulate it in a way that you need to.
Right.
Okay. So in terms of the other engines we have machine learning graph engines. Huge amount of additional functions that we've been placed into here. So if you call one of these functions like neural network functions, decision trees, these engines would actually respond to that function call, work on the data set that you're actually using from your SQL engine, and then pass that data result back into your SQL query and either continue processing for other steps or respond back to the end user.
Right. So this is something that can be used both for data in transit and as part of some kind of analytical workflow?
Very much for the analytical workflow, yeah.
Okay.
Yeah. Okay. So if you are a data scientist making use of your favorite tool sets like maybe Python things, then you could call one of these functions from your Python script and it would make use of the data set you've identified on the database, call up a graphing function or clustering or something like that, and actually manipulate that data to respond to your Python.
What if you have Python code that you've already written and you're happy and it does a number of things with NumPy or something like that? Is that something you can make use of?
Well, we actually have created some Python libraries which expose these functions into your Python code.
Okay.
And similar with R as well. Now, if you've got existing code, then you may have to make some small changes to that code.
Okay.
But actually, we could still use the Python Teradata SQL driver to expose the Teradata SQL database, and if you're extracting data into your Python code, you could still do that.
Right.
But you're still making use of the Teradata platform, or you can rewrite your code to make use of these additional libraries. So like we have one for R, so expose it into your favorite R tool if you want to, and we actually have one for Python as well.
So you'd effectively be using Python to script computation on the Teradata platform?
Yes, pretty much so. Yeah. So by using the new libraries and calling a function, it pushes down an optimized query into the database platform to respond to that. So you're actually making use of the parallelism of the Teradata Vantage box to actually respond to your query, and you then get the access to vast amounts of data that we store in Teradata.
This reminds me a little bit of Spark in a sense, I guess, where you script a number of things and send a command and you have a graph of stuff that happens. Obviously the query, the engine builds a query that's optimized for Teradata's platform. Is that sort of how it works? And
very similar, yes.
Do those two ecosystems fit together or overlap, competitors?
They kind of overlap. In our future release, and I've got a slide a little later on about what our roadmap is for the next year or so, then Spark is one of the engines we will be adding to this.
Okay.
So today we have the machine learning engine and the graph engine. Our intention is to add to that, and Spark will be one of those options that we add in the future.
Okay, so they'll be living together.
Absolutely, knitted together, same set of data, sitting within the Teradata ecosystem or a Teradata-enabled ecosystem, and actually use Spark or graph or machine learning or SQL to actually access your data.
Okay, makes sense.
Okay, so. The other aspect of Vantage, and one of the things that when we talk about pervasive data intelligence is kind of one of our key themes, and pervasive, it's basically access to all your data, no matter where it exists. And this query GUI, which is our virtualization capability, enables that. So our relational platform and our SQL engine, graph engine, all connected to our high-speed interconnect. So that's for moving data around very quickly. But the other platforms that we access, like Cloudera and Cassandra and things, we can interact with those via this query grid, this virtualization layer. Query grid enables us to effectively expose all these other tools and all these data stores inside of the Teradata sequence.
As if they were part of the database?
Absolutely, so that you would see them as a foreign table, effectively.
Okay.
So you would just select from that table, and that query would then run out to Cloudera. And we have some of these are native and optimized, so it would the query sent to Hadoop, to Hive, would be optimized for that technology.
Okay.
Other ones that we don't support natively, so like Postgres, for example, then we would make use of Presto as an interface into those things. So they're not as optimized, but you still would be pushing down a query to these systems, subset the data you want, and then pull that data back into to respond.
So that's interesting, and I suppose there are varying degrees of how interoperable these different platforms are. One thing I can imagine that's nice about funneling your queries into one place to reach many data sources is that you could take advantage of things like access control or perhaps user management and that kind of thing through Teradata.
Absolutely.
Is that something that works?
That's exactly how it works. So from the Teradata engine where the user would come in here, then we would you can manage the security at this point. So some users may not have access to data in Cloudera. Your permissions are just not available at the Teradata end.
Right.
Okay. But you can also manage permissions between the two systems as well. So you can make sure that this user over here can only access certain sets of data in the target
Cloudera.
Yeah.
Right.
Yeah. So it's a very very clever technology to actually expose extra data. So this is why we talk about pervasive. Data exists in lots of different places. Bringing it together, so it doesn't mean bringing it together one platform, one physical storage. It actually means exposing it so you can get access to it from one platform.
Cool. What's next on the Teradata roadmap?
Okay, so first of all, coming a little bit later this year, so Q3, Q4, then we'll have this what we call native object store. So today we only have the Teradata relational data store as a native access. We're actually adding S3 and Azure Blob Store as native to Teradata, to the thing. So
nice.
SQL Engine will actually be able to see this, as will the machine learning engine and graph engines be able to see data stores that you're keeping in S3. So it becomes a native.
I think that's important now when everybody's going cloud first.
Absolutely, absolutely, and this means that we're minimizing the amount of data that's moving around, but exposing all the data at the same time. And you combine it with data from the relational store along with the object store in a very natural way of SQL.
Cool.
And then further on from that, in the future, we're starting to add. We're looking to add Spark and TensorFlow initially, and then we've got SAS VR on here as well. But we'll also support. We understand that the market changes rapidly today, so custom engines here. We'll keep adding the additional engines to this as well. And we're looking to start supporting more languages natively. So Scala, Go, for example.
Add Julia, one of the best languages for science right now.
We'll see. But yeah, so we're starting to extend and support additional things into the Teradata Vantage platform, and this is all coming from this is the roadmap for the future. There's no set dates for this yet, but certainly the object store will be later this year.
All right, that sounds super exciting.
Yep.
Thank you for the tech updates.
My pleasure.
We will be seeing you very shortly now on the main stage for closing remarks. Stay tuned.